Welcome to Brain Vision.
Calculate the first three wavelengths of the Paschen series. So the equation that governs the Paschen series is 1 over lambda is equal to the Rydberg constant times 1 over 3 squared minus 1 over n squared. So the first three wavelengths are going to be n equals 4, n equals 5, and n equals 6. So I flipped the equation. So we want to solve for lambda. So lambda is equal to the inverse of the value that's on the right side of the equation. So I took everything on the right side of the equation and raised it to the -1. So now let's start with the first wavelength. So this is going to be for n is equal to 4. So the transition from 4 to 3. So we can call this lambda 1 because it's the first wavelength in this series. And this is just going to be equal to the Rydberg constant multiplied by, we have 1 over 3 squared, which is 9, minus 1 over 4 squared, which is 16. Of course, all of this is going to get raised to the -1. The Rydberg constant here is 1.097 times 10 to the 7 inverse meters. So plugging that value in and carrying out this operation, we find that the first wavelength is equal to 1,875 times 10 to the -9 meters, or 1,875 nanometers. We can box that in as the solution for the first part of the question. So now we're just going to do the exact same thing for r equals 5, or n equals 5 and n equals 6. So n equals 5. We have lambda 2. And again, this is equal to the Rydberg constant multiplied by 1 over 9 squared minus 1 over 3 squared, which is 9, minus 1 over 5 squared, which is 25. So 1 over 9 minus 1 over 25. I'll raise all of this to the -1. Carry out this calculation. We find that this is equal to 1,281 times 10 to the -9 meters, or 1,281 nanometers. It's very common for wavelengths to be written in units of nanometers, so I'm going to write all of mine in units of nanometers. And the third wavelength is for the n equals 6 to n equals 3 transition. So here we have n equals 6 and lambda 3. Same equation. I'm just replacing the n squared with 6 squared. So we have 1 over 3 squared, which is 9, minus 1 over 6 squared, which is 36. So we have 1 over 9 minus 1 over 36. All this raised to the -1. Carrying out this calculation, we find that this value is equal to 1,094 times 10 to the -9 meters, or 1,094 nanometers. So we can box that in as the final part of our solution for part A. Part B says, what part of the electromagnetic spectrum are these wavelengths? So I looked this up. I just looked up wavelengths of electromagnetic spectrum, and it gives you ranges for all the different wavelengths of the electromagnetic spectrum. And these wavelengths happen to fall in the far infrared part of the spectrum. So we can say far infrared region. It's a little bit larger, so it's easier to read. And we can box this in as the solution for part B, which is the final part of the question.